Hello, everybody. Hello, one person that's ever going to watch this video.
That's me.
Okay, we're talking about,
I love you.
so we've been kind of developing your graphing sense more than being really exact. We're going to talk about two things the next 2 days. One of them is called end behavior. The other is continuity. We'll do it Tuesday, but it's one section. Okay? So, end behavior is probably your first study of the infinite. Correct? Okay. You know what infinity is?
Yeah.
What is it?
Never ending. Wasted all.
Okay. Never end. So, is it some exact number?
No.
No, it's not. Okay? It's not an exact number. It is a concept.
Style life.
Forever. Right?
I love this nonsense stuff.
So, have in mind that what you're going to be looking at today is not. You're going to be looking at the graph, but we're going to be looking at what happens in the infinite. Okay, so you're going to have to kind of get in your mind that you need to picture these graphs going on and what happens out here and out that direction, or that direction, or that direction. Okay. So if I draw a graph real quick, just sketch something. So the question of the day would be, what happens that direction? And how do you say it? So, what's happening here? Okay, what is going to positive infinity? In what direction though? Right? Up? Okay, both of them in fact, right? I can pick a really big X number, it's going to make me a really big Y number, right? So we would say as X goes to infinity, because X is our basis, right? X is our function basis.
So x equals infinity.
X is going a long ways that way. What happens to Y?
So if x equals infinity, y equals infinity.
Not equals. We would say
Goes on.
goes to, or more mathematically approaches.
How do you approach infinity?
This would be a better word. Goes to is kind of a more conceptual idea. Approaches is more mathematical term. Okay, so as X approaches infinity, Y approaches infinity. And that's telling us the graph is going that direction. Right?
Negative infinity, you just look at.
Which way is X going?
Negative infinity.
What happens to Y? Positive, so it's X negative, Y positive, right? Okay. So again, you're used to your location-based math where we graph stuff and it's there, right? Now you're starting to talk about what happens in places you can't see in front of you.
Why would
you have, where would you?
Do you really want to know?
Yeah.
See you next year in calculus.
No, don't be.
No, this is kind of there are lots of applications of this. You get into that. You're in the very basic forms of it, where you probably won't see a lot of those applications. But when you build your base up, you get to the next few levels. They start.
So like BC calc, it'll make some sense.
No.
Shut up.
Maybe. We hit this in the first 2 weeks of school. Well, it's basically Calc 1 and 2.
Because math doesn't have
Knowing this information,
I woke up late.
Really?
Do your makeup?
Wow.
Seriously?
okay,
Everyone.
knowing your families of functions, can you tell me what that function is? What? It's a cubic.
Cubic.
Cubic negative cubic.
There you go. X cubed goes this way, right? So I have flipped it across the x-axis.
Oh,
Describe the end behavior of that function.
Wait, you have to.
Get caught up, you write it down, get caught up. That, you mean that? Yeah, it means when you have a positive x, you got negative x. Okay, so describe the end behavior as
There is no x approaching negative.
x goes to infinity. What happens to the y? It goes down, right? Now what's the other one? Negatives, okay? Y goes to positive.
Oh my God. So simple.
Because you have x going to infinity. And you have x going to negative. You have to address both ways. Yeah, make sure you address both directions. Are you okay with that?
You always write it with an x before y.
Yes, because x is the basis of our function. It's the independent variable. Y is the dependent variable, right? But you get because they describe both sides. Now, regarding functions, have you ever heard of increasing and decreasing? The words. So,
Yes.
if you had the word increasing, what would you say that means? Just
Going up gradually.
okay, so which side of this graph would be increasing? we all in agreement that one's increasing?
Yeah.
How about this one? Ah, there's always an argument here.
Well, it depends on what you're looking at for increasing and decreasing. You're looking at X values or Y values.
Yeah.
You're looking at X values and that's increasing. You're looking at Y values and both increasing.
Are we looking at X values or Y values?
Why?
Y values. This is actually,
Only makes sense to both sides are Y values.
we have to go from left to right.
Oh, so
There's the key, is the direction you're traveling. So decreasing. If the Y values, you start on the left, decreasing, now they're increasing. Right?
Wait, so both?
That's because the X value is negative to positive when we go left to right.
Wait, so it is decreasing over here?
Over here. So what's that interval? Negative infinity to what? That's
That's from 0 to infinity.
this one, yes, increasing from 0 to infinity. Why do I not include 0? So if I'm writing this in
Is it from 0 to the origin?
inequality notation, see there's no
What are you doing?
there's no equal sign. I'm writing this in inequality notation.
The 0 is not a
What happens when you get here? You're not going up or down, you're flat. So this point right here is flat. So, what about this one? Decreasing? On what interval? Does it stop decreasing there? So you don't have to separate it with these both keys. Okay. So this is decreasing on its whole interval.
When you get decreasing and increasing, you're looking at slope.
That's exactly what it's describing. Decreasing, negative slope. So that's actually really good. Oh, sorry there. Negative slope. So increasing would be positive slope. Okay. We're dancing around calculus like crazy. It's awesome.
Whoa, you
Go to the
lost-
hand up.
Okay.
Mason.
For the x cubed, why is it negative infinity to positive infinity? It doesn't have to go into positive graph.
That's the interval of x that is decreasing on.
What? Okay.
So if I were to write it in inequality notation, x is from negative infinity to infinity is decreasing. Separate it from this. Yeah.
So do you have to separate them out? Like what we do with the parabola?
If
Or
it changes direction, they have to be separate intervals because it's increasing and decreasing. So I gave you the graphs here. You're going to be asked to graph some of these things and then describe end behavior and increasing and decreasing behavior, okay? Jeff, read it live. We played it.
HB.
Yeah, it's a good game. Records match.
It's away, right?
Yeah. Okay. That's it. Good. So, again, it's not, it's more of a conceptual base, so, Some of these problems are gonna be continuity questions. If you wanna start this weekend, avoid the continuity questions. Just focus on in behavior and monotonicity, I guess what some people call it, increasing and decreasing behavior. So ignore continuity for now if you want to start. Just focus on what we did today. Now, I'm giving you 15 minutes to take advantage of. Please do that.
I always think that whenever
What is that
it's
stuff
assigned
about?
homework, you usually it's always should be all in there.
There it is. Oh, yeah, what is that about to say?
Do Wednesday.
Oh, okay.
Let's not do it until Wednesday.
What?
Give you a little practice.
Because one from the 90s looks like actually the
Heart attack.
Yeah, I heard that.